In this video, we will work through a quick exercise that demonstrates how to check the verticality of a wall in a point cloud. We begin by starting a new empty model for this specific elevation and load the point cloud we want to use. To simplify the view, we will clip the point cloud to just the part we need for this demonstration. A section is used to isolate the part of the wall we want to check. There are many ways to generate sections, but for elevations it's best to use a baseline that will give us repeatable results. To generate the baseline, we will place a couple of points that draw a line at the base of the wall at either end. Clicking Always Visible makes it easier to see and check. Now we have a baseline, we can use the Section from Baseline option to snap a vertical section to the front of the building. If the height of the section is not suitable, change it and then repeat this operation so that it fully covers the building top to bottom. Note the section is flipped, so we need to reverse it. Next, we will export an image of what the section is seeing. This is not strictly necessary, but it helps to provide context later. Make sure to enable elevation image and elevation coordinates. Otherwise, the image will not be suitable for our needs. Give the file a suitable name and set the image type to ECW. Click Yes when asked if you want to create an elevation from the current section. This flips the 2D model into the same coordinate system as the section, so we are now viewing it from the side. We can now test the image lines up with the baseline by back-clothing it into the model view. That all seems to line up, so we can continue to extracting some points over the surface of the wall. From the Point Cloud I/O tab, click Use Section so that the points we require are projected onto the wall and not vertically onto the point cloud. Set the interval and interpolation distances to sample the surface of the wall at suitably regular intervals. We also need to enable the Create as Points option so that we get actual XYZ survey points and not a surface. Align to Spacing sets the origin of the grid to 0, 0, and Show Through Cloud allows us to see the points clearly. Click Preview Grid to generate the points we need on the surface of the wall. Switching the display mode of the point cloud to off temporarily lets us see the points more clearly. Assuming we are happy with the points and their distribution, click on Create Grid to add them to the model. Switch to the model view and the points are clearly visible. To make it easier to see what's happening, we will temporarily turn the image off. We have effectively laid the wall down flat, and the height of the point can be seen highlighted here. Because the level is negative, we have to add that value to all the points in order to raise it to 0. By doing so, all the other points levels will also be raised by the same amount and effectively now be deviations from 0. After adding the required offset, we can see the level of the bottom left point is 0 as it should be. Generating the surface and enabling shading on the left of the screen gives us a basic rendering of what is above and below 0. The points we have in the model were added without a code, so they are being drawn with default settings. If we recode them to a spot level code, we should then see level annotation. Note, these values are the deviations from the level of the origin point. In other words, their deviation from the vertical. Switching back to the model view, we can now see these offsets from the vertical graphically. You can also think of negative values as being inside the building and positive ones outside. To make it easier to understand, we will configure the code to plot these offsets in millimeters rather than meters. To do this, we need to uncheck the height section of the code and instead enable the text part. In its text box, we enter %.0 open brackets, pz-d multiplied by 1000 close brackets, and add on the end for millimeters. Instead of simple red text over the drawing, we will create a custom color scheme that shades the text based on its deviation from 0. All we have to do is set the height shading to custom intervals, and then enter in the boundary colors we want to use. Finally, set the interval to a smaller value so we see the graduations. 20 millimeters is not small enough, so let's try 10 millimeters. Turning the image back on and the triangles and contours off starts to provide some context for where on the wall the differences are. The text is still just red though. To make it follow the same shading scheme as the DTM, we need to change some settings. Click on a spot level point to allow us to start to change its settings. Under the Text tab for the spot level code, enable the height shading option to make it eligible. Now to invoke the colors for the text, enable the height shading checkbox in the DTM settings. The image is okay, but it's washing out the text, so let's draw in the walls and windows instead. Then we can remove the image. To do this, we enter the Cadd with model screen that shows us the Cadd tools, but with the model data in the background. Now we can set the layer, style and color to use before we start detailing the windows. Using the image as a reference, the first rectangle depicts the outer frame of the first window. Now we can add a first window in with a rectangle, then copy it horizontally to give us the entire window. Then copy everything horizontally and vertically as required to fill in the windows where they are needed. Finally, add in the walls and then close the Cadd window. Back in the model view, turn the image off and delete the points which are covering the windows, giving false positive readings. That concludes this presentation.